Welcome to Oregon State University Food Science and Technology's Farm to Fork webinar series. My name is Sherry Cole. I'm the director of FST's Sustainable Food Manufacturing Program, and I'll be your moderator today. Our intention with this series is really to expand the conversation about food systems and how they work and the things that are underway to change them and the people behind that change. We really appreciate you taking the time to join us today. We know everybody is really busy, and this topic will be, yet another really great, exciting, and timely one for you. So thank you. We really want to make sure that the stories that we bring you illustrate the sheer diversity of what's happening in food systems, whether that's land or sea, processes, ingredients. And so we really want to make sure that these stories reflect that diversity. Before I introduce today's presentation, I want to just briefly run through some logistics. First, we're recording the presentation. And so we do that to make sure that if you want to go back, it's easy for you to do that, or you can share with others. And you'll find that on our Farm to Fork webinar site, and we'll post a link at the end of today's presentation. The other thing is we really do want this to be as much of a conversation as it can be. And so we've reserved the last 15 minutes for your questions. At the bottom of your screen, you'll see the Q&A feature. Please post your questions throughout the talk. And you'll also see in Q&A the ability to upvote questions that you think are really interesting, and then we'll get to those first. And so I'll put some reminders in if you get absorbed, but we really do want to hear from you. So thanks for making the time to share your questions. So it's my pleasure to introduce today's presentation, How Dulse and Other Seaweeds Will Shape the Future of Food. Please join me in welcoming Chuck Toombs.
Thanks very much. I appreciate that, Sherry, for the warm introduction. I'd like to start by saying I've got to squeeze a lot of information in a short period of time, but I wanted to start by reaching out to all the people that came to the webinar today and said that, without Oregon State's backing and stuff, none of this would be possible, and that the cooperation that we have both intra-college and within the university and without the university, I think is on par with every other large institution in the world. So we're very proud to be here today. So I'm going to give a short talk on how dulse and other seaweeds will shape the future of food. So the way I thought the best way to do that is I'm going to spend about the first quarter of the time that's been allotted to me just sort of setting up the problem, and then I was going to explain to the group how we're going to solve the problem, and then that'll pave the way for questions and answers and hopefully some good discussion. So that's kind of where I'm going to head with this today as we go further. So the major question, or the academic question that we're going to answer today for everybody, or I'm going to try, is why now? Why now? Agriculture, at least the way we've known it, has been around for 12,000 years. We have Oregon State University is one of the finest land grant institutions in the world, have been pioneering and working on agriculture for many, many years. We've had government legislation that has sponsored land grant institutions and stuff. But question then has become, seaweed's been around, and it's actually been consumed far longer than conventional agriculture. So the question is, why now? And it really comes down to what we call a moonshot question. And I'm going to spend the next 3 slides sort of setting this up, and then we can go into how we're going to fix that, and why the world's going to be a better place at the end of all of this. So the moonshot question basically is, can we feed 9.8 billion people in 2050 without using more land while lowering carbon emissions and reducing water consumption? Now that's a big sentence. It's got a lot in it. It has a lot of topics, and I'm going to just go through a few of these relative to ag and what's going to happen. So the moonshot question is, first of all, global food systems emissions were 18 gigatons, and that's about 34% of global greenhouse gas emissions. So right off the bat, food systems is a target, or looking at this of how can we reduce greenhouse gases, and how can the food system participate in that? If you also look at, even if we take greenhouse gas emissions to net zero, the food system alone, non-food system, if we take greenhouse gas emissions to zero, the food system alone will exceed the global target that we've set for 1.5 degrees centigrade. So even if everybody else does their job, food's going to contribute to what we think will be an unstable atmosphere in the future for our kids and grandkids. So the problem still exists. 14.5% of the global food system emissions all come from livestock-based agriculture. That's a fact that we have to deal with. 77% of agriculture land is used for livestock production as for meat and dairy. Now, we all know that we only have a limited amount of land, and that's going to be an issue that we're going to have to deal with in the future in terms of how we're going to get productivity enough to feed everybody as we go. Plant-based proteins and plant-based products have been on trend probably in a big way since Beyond Meat went public during the pandemic. I've been involved with seaweed since 2015, and the particular seaweed we started with was, of course, dulse, which is high protein. So it's always been in the back of our heads, but it didn't really start generating until Beyond Meat went public and the valuations in the market started skyrocketing for people and the investment community willing to pay a premium for that. And there is an answer because plant-based products can reduce carbon emissions. So we do have a way out in terms of answering this global moonshot question of can we feed 9.5, almost 10 billion people in 2050. But the outlook now is not so bright in the sense that this is a chart of global meat production. There's no sign of it slowing down. Matter of fact, in some cases, it's accelerating. The reason for this is tastes are changing, global wealth is increasing, and as global wealth increases, meat is an attractive product, and it has been for many, many years. So we've got a real issue here from the standpoint of a marketing perspective, though it's a real nice challenge to have because we can solve the answer, create value, and go from there. Now, as we in the US at least and many other countries operate in some form of free market, and we know there's an issue, we know there's a problem, and we go for to try to regulate as much as we possibly can. This is an example in 1990 with the food nutrition fact label that was put on. That's a thing that, you know, we can put on food to have people look and see what they're eating and whether they think they're eating the right thing. And I just point out that it's been around for now, you know, many years. And this is a survey is that although 2/3 of the people typically read food labels, 2/3 of the people they not only understand, but they're skeptical of the actual results as it goes. You may have seen this as well. This is the layout or the graph presented about greenhouse gas emissions per kilogram of food product, and of course, this is the crux of what we're trying to solve relative to the moonshot question about how to feed. So we can see this list. I've added seaweed down here at the bottom because it wasn't even put in the initial list, but that's going to be part as I get through this of the answer to the question. So how we developed the answer to the question started actually as an academic exercise in a classroom setting in the College of Business, where we were teaching a marketing class and gave the students the question of why can't dulse be the new kale? This was back when kale was becoming popular. I remember my wife feeding it to me and thinking that kale didn't taste very good. So we thought, well, maybe we could turn a seaweed into kale. And that resulted in quite a bit of interest. The biggest interest came in the form that we had let a few restaurants try it, and they gave us feedback that this particular dulse that had been growing in Chris Langdon's lab for over 25 years, if you put it into a fryer, it tastes like bacon. And this went viral. Again, this is back in 2015. And I didn't even know what viral was. It was brand new to the university. But if you did a Google trend search on dulse, it would look something like this. And I can remember this graph of people wanting to search for dulse resulted in seaweed that tastes like bacon, resulted in all this media inquiries around the world. And we knew that this was somewhat spectacular. And it was even informed by me because I got a call from Ed Ray, who at the time was president of the university. And he said, Chuck, you know, we just started tracking internet traffic on Oregon State University's website. And he said, this is the second biggest thing that's ever hit Oregon State University. And of course, I was very pleased, brand new professor at Oregon State University. And but I asked him who the first was. And we looked at that with Dulce. And apparently about half a year before I got there, the library girl was someone that had privileges in the library and got more hits than we did as a result of that. So that's exactly how we got to where we're at in terms of Dulce. Now, what we've tried to accomplish since then is develop a business and try to answer the question of how can we present this to the markets to achieve both create value and create a substantive change to how we're going to do that. And let me explain to you a little bit of a timeline on how that has actually gone. Oregon Seaweed right now is the largest on-land seaweed farm in the United States. We're pioneers in clonal seaweed aquaculture. Now, let me just spend a little bit of time explaining what that is, because clonal seaweed agriculture is a seaweed that grows clonally, meaning it doesn't go through a complicated sexual reproductive cycle. The nearest thing that I can describe it, it's like bananas, because bananas all grow clonally and they grow exactly the same. And that's what we've focused on growing, because we think it is it's the best way to create the product that we want and the amount of product that we want to do it. Our first farm was in Bandon, Oregon. Our second farm we opened last year is in Garibaldi, Oregon. And we just recently, at the turn of the year, received an investment from Catapult Ocean, an equity investment. And to give a little pitch to Catapult Ocean is, as we were looking out for partners around the world to help us grow this business, we wanted to, and we knew we were making a positive impact to both the world and hopefully to investors' returns. We reached out and we developed a relationship with Catapult Ocean, and they're the largest ocean impact investors in the world. They're out of Oslo, Norway, and they became a partner with Oregon Seaweed at the first of the year. So they've encouraged us to expand the business. They see the value in it, and we're going to do exactly that. We're going to be announcing this year a third facility, which will have both farming and processing on it. And we have plans to scale very quickly all around the world with what we've got. Now, let me explain to you what our vision is, because it's very aggressive, and it would probably lead to some very good discussion and some very good questions at the end of this presentation. We want to create the most successful vertically integrated agribusiness in the world. And we want to lead the world's transition to sustainably grown and processed fresh foods and ingredients from premium seaweeds using proprietary controlled environment agriculture. Now, that's a lot in one word, but basically we think we can reshape the entire supply chain in agribusiness around a sustainable product that can be used as an ingredient, but also as a fresh product in many, many, many cases. And this can be scaled worldwide very quickly. So we're going to be producing, the key thing that we're going to be doing is we're going to be producing high protein clonal seaweeds, and we're going to be processing them on site. So we're going to have a farm and a processing facility all together in one site. Now, the value to that is I could go into another lecture on that, but basically the real value in that exists in that the only way to get maximum value out of seaweeds is to process it immediately. And the only way to do that is to grow it on land. And the advantage of growing it on land is that we can feed it, we can watch it, we can control it, we can get the exact output. But one of the biggest things is that we can predict how much is going to grow, and we can marry the farm size with the processing facility so that we have a processing facility that's going 7 days a week, 24 hours a day, 365 days a year. And this is innovative in entire agriculture, if you look at it, because we don't need silos, we don't need storage, we don't need any of this stuff. So we're going to be able to process this immediately and also avoid all the transportation, et cetera, et cetera. The products we're going to be making out of it is we've already developed a fresh seaweed market into retail, into food service, into restaurants. That's worth expanding. We think that's a great area. Another major area of concentration for us is in what we call folded proteins, and these are functional proteins that we've been able to extract from the seaweed that have tremendous properties in plant-based meats and plant-based meat, fish, et cetera, et cetera. So this has been a very big area of interest for us that we're gonna concentrate on. The other thing is we think there's a real value in creating ingredients from the dulse as well as soil amendments. Now, the soil amendments, I'm not going to have a lot of time to spend today to discuss, but basically we've got a method that we can create carbon products out of the residue so that we can functionally be marketing a carbon negative protein into the marketplace. So our products, again, to reinforce this, we're going to have fresh seaweed, which we're already doing, specialty food service. We think the market is going to grow. We see no reason why fresh seaweed can't sit next to kale in the produce aisle. We've had some minor tests on that have showed a great deal of promise. Dried seaweed at groceries, of course. But again, we have the functional ingredients like protein, of course, iodine, and bromoform, which you may have heard in the press about feeding red seaweeds to cattle reduces methane reduction. We do have that as a particular component of our seaweed. I'm deferring that issue a lot to our scientists who are still working on the efficacy of that as we look at that as a new product moving forward. So basically what we're doing is we're going to reinvent the supply chain for food. And the way we're going to do that is we're going to mass produce under controlled environment agriculture, which is a growing field, as you might noticed, with large greenhouses and large high-tech greenhouses that are growing tomatoes and this sort of thing. We're going to apply both that to it as well as other disciplines. We're going to process on site, and we're going to transition as much as we can the entire world's food supply to sustainability. Again, as we look at this, we've got a problem, a protein demand issue, where protein demand is growing, and we don't have enough protein to feed everybody. There's estimates that 1 billion people are currently protein deficient. And the current methods, as I said in the first half of the presentation, are just not going to work. They're just not going to work. We can't grow our way out of this problem using conventional meats and these other things because the greenhouse gas emissions are too high. So we're an answer, and we're one answer that we think is very viable and cost effective. And plus, the seaweed tastes like bacon. Soil degradation is accelerating. This is a real problem for land-based agriculture. They're doing lots and lots to work on it. And again, we all know there's too much carbon in the atmosphere. So we've got this sort of plant mechanism that can address all those opportunities. So again, our solution is we're going to apply these concepts of high protein, clonal red seaweeds. And again, I want to emphasize that in particular, because when you notice, and you'll see in the news, these giant forests of seaweed being grown in the open ocean, that's a separate technology that we think may have in the future. They've been working on that for ARPA, and has been working on that for about 25 years to try to figure out how to do that. We've figured this out already, so that's good news. We're gonna have these plants scale. We're gonna make efficient proteins and carbon and soil amendments on site and be able to market carbon negative products like proteins to everybody. Kind of in the field is that we collaborate now not only with our colleagues at Oregon State University, but we now have collaborations. Of course, I mentioned Catapult Ocean is an equity investor that has opened many doors to Europe and the rest of the world. But we like to keep that hometown. We've got several active research projects going on. We've got one going on right now in nutrition and public health, where they're actually extracting our proteins and looking at digestibility features, which is really important. We're looking at this also from a horticulture standpoint, because really what we're doing is we're just growing in a horticulture setting. And if we can apply all they've learned in horticulture over many years, again, this is the real advantage of being part of a large university. We also are working with Stanford on a project. They've got some really cutting edge things in terms of energy savings and artificial intelligence that we're excited about. We've got a project coming on with Greg Rohr in chemical engineering on Gracilaria. That's another red seaweed that's clonally developed. We think we can even improve on our current optimization there. And we've got scheduled Ulva and Nori and some of the other big ones. And I think this is going to be one of my last slides, and I just wanted to make the argument, because the argument has been very, the complex or the difficult argument has, for me to be able to make, is that that long-term, the economic benefits to growing seaweed will primarily exist on land, not in the ocean. And the reason I say that is because, of course, we can control the growth. We can control, we can feed it, we can monitor it, we can change conditions to alter its natural behavior so that we can get the product we want out of it. And I'll just end, I've got this slide here. This is from the ARPA slide, oh, excuse me. This is from the slides of the Mariner program, and where they compare the yield, acre yield of field corn with giant kelp, which is a focus area of them. And the yields here about 30 dry metric tons per hectare. And what we've experienced in our limited growth in our two farms has been anywhere between 48 and 87 dry metric tons per hectare. So this is the other way to look at this is if you look at the amount of geography that's devoted to soy, producing soy in the United States, that would be, the geography would be about the size of North Dakota and South Dakota combined. And we can grow with our product, we can grow enough protein to meet that exact amount of protein in a state the size of South Carolina. This is our final slide. This is at the end of the commercialization about what we've done. We've been able to commercialize the product, working with several large retailers. Also, we've as you might imagine, we've spent a lot of time working with the growing plant-based meat industry. Our goal is we want to be a strategic ingredient to that industry, because we've proven that there are several proteins which really have a lot of value, that can bring out very good functions, and that can also bring out very good taste. Because in the end, one of the things that really vaulted us on the world stage was the fact that we declared that we had a seaweed that tastes like bacon. And although there's a lot of urban legend now surrounding that whole episode, what it really hit me was, in the sense that it really hit me was that you really can't shame people into changing behavior. What you have to do is you have to come up with a better product at a lower price. And if you can do that, and add the value of reducing greenhouse gas, then you're ahead of the game as well. So that's kind of it in a nutshell. I will, let's see, stop sharing, and that's kind of my pitch in a nutshell. I hope I didn't run out too bad over time, Sherry, but I'm happy to continue the conversation and wherever we go from here.
Excellent. No, we're fine on time. So we have about 15 minutes for questions, and I'm happy to say that a lot of you have posted them. If you have questions, please continue to post those in the Q&A feed and upvote. If we can't get to them today, we will make sure that we download and share those with Chuck, and he'd be happy to get back to you offline. So first question is from Olivier, and he asks, has someone investigated the chemistry underlying the bacon flavor?
The answer is a little bit, and I'm not dodging your question. I'm from the College of Business, and I'm in the marketing department. So my job is to take those things and sell them. I do know that some of the research that we've done internally at OSU in terms of amino acid comparisons is that the relative high level of a glutamic acid or in the dulse itself to our people leads that to have the meaty texture. That's part of it. I hope that answers that.
Thank you. Next question. How often do you need to change the water during cultivation? What are your sources of water, and what is the water footprint of your plants?
That's a great question. Currently, because we have our two farms in Bandon and Garibaldi, and what we're doing with those is we're bringing fresh seawater in from the ocean at high tide, and we're fortunate in Oregon, at least in the summertime, to have a major upwelling, which occurs. So we take advantage of that upwelling, and we bring highly nutritious water in at high tide, which solves two problems. It brings nutrition in, but it also brings cool seawater. And one of the things that is necessary with this particular, at least the dulse that we're growing, this particular strain, is that it has to be below 18 degrees Celsius to survive. So we need to be cognizant of the temperature. So the answer to your question specifically is we use fresh water. We do filter it, and we do UV it to kill bacteria and other things. But we use the water to feed the dulse, but we also use it to circulate to control temperature.
Thank you. Next question, Michelle asks, how will you upscale? Will you use flow through, semi-recirculation, or full recirculation?
In scaling, we've got actually three projects going on. One of them is to take a look at just on land, period. In other words, on land growth of that. That would be fabricating seaweed, having a closed loop system, and doing it in Canton, Ohio, for example. If we can, we have people that think we can actually do that as effectively as growing it near the ocean. So the product needs the way I've answered this, the reason we bubble or we use recirculating tanks is because we have the ability to get the dulse or the seaweed to grow in a three-dimensional setting, which gives us our productivity on a per square meter basis. Okay, that's really the key to the growth there. So we do need to circulate the product, and we do need, and we can actually do it in a closed loop system. The question then becomes economics and which one is the best for us. I hope that answers that one.
Thank you. Rebecca asks, don't you lose, oh, sorry, scroll out of view. Rebecca asks, don't you lose some of the value by growing it on land rather than in the ocean? How does that impact the moonshot question?
Yeah, great question. Actually, I think it's the reverse in the fact that the farms that we're on right now, we're on land that's never been used for anything in particular. So we're using land that can't be, that nothing else has been used before. The argument for growing it on land is simply the argument that we can produce a higher quality product that meets the needs of our consumers much better. Dulse, you can grow kelp in the open ocean, and that's great, and it will stay there. The problem with the kelp is that the ingredients in the kelp, don't have as high a value as what we're growing. There has been 2 experiments done by a Humboldt State University, and there's a professor down there that I can't remember his name, but anyway, he's done it. He's tried to grow dulse online in Humboldt Bay, and he's done 2 experiments. Each have failed, and for a number of reasons. Number one is that the dulse likes to grow in clumps. It doesn't like to grow in strips. And the second way is that it's because it's such a good quality, nutritious seaweed, it gets eaten by anybody that wants to eat it that's a little critter in the ocean. So it competes with those resources. That's the answer to that.
Okay. Rebecca asks, what grocery stores are selling fresh seaweed? Why is that hard to find right now?
Great question. I wish every grocery store had it. And I've got a great answer to that. And it is that, again, we run up against regulations in this area, is that we can sell fresh seaweed through specialty foods distributors to restaurants because we're selling it along goods that have been foraged and other products like foraged mushrooms, fiddlehead ferns, these exotic sort of products. These have a lower regulation threshold than if we were to go to a Charlie's Produce, which we have, and we were to get turned on to a Whole Foods or this sort of thing. That requires much more regulation, third-party audits, and of course, there is no third-party audit for seaweed yet because no one's done what we're doing. So we're in new territory with that. My partner, Jason Bush, is skilled in this area. He's currently the director of the Oregon or the Pacific Ocean Energy Trust, and he's handling those regulatory issues at this moment.
Thank you. Finley asks, on your website, you mentioned the seaweed industry becoming larger than the wine industry within 5 years. Where are we on this timeline?
I'm accelerating that. I think we'll be bigger than the wine industry in 5 years. The question now just is that, can we expand? Can we expand quick enough to meet the demand that we know is already there? We've been working with some of the largest plant-based meat companies in the world, and they want us to grow. They want to use our product. So we've taken the necessary steps. The first one, of course, is to access capital markets through Catapult, which is our partner in Europe, and we see the ability to grow this stuff very quickly all around the world.
Bert asks, what will be the cost, US dollars per kilogram, at large scale production?
That's a great question. I think that I don't have a good answer for that. Cost per kilogram, large.
Or maybe another way, how are you thinking about and communicating about cost?
Yeah. Well, as an owner of a company, I wouldn't communicate cost. I would only communicate price. So what I would do is what we've been able to, I can explain what we've been able to do. We've been able to create functional products or get ingredients and functional ingredients that can compete with what's existing in the marketplace. So we think, and again, that actually is a great, that's a great question, because I was on a podcast with Bruce Friedrich, not a podcast, but a conversation with Bruce Friedrich, who is he runs the Good Food Institute. And he was the guy that he's a great guy, and that's a great organization. It's an entire organization devoted to alternative proteins. And Bruce used to run PETA, and he used to be the guy that ran around and threw blood on models that were wearing furs and stuff. He was this guy in the 80s, was running around. He was a very big activist with PETA. And he reflected back on his career, and he realized that he really didn't change any behavior. And that's why he formed the Good Food Institute, which was this idea that they can create these products that are better tasting, better quality, better price. So to answer Bert's question is, we're going to price our product to compete with anybody that we need to, and simultaneously reduce our marginal cost of production so that we are extremely profitable and return an exceptional return to our shareholders.
Thank you. Antonia asks, what would you say is the aspect of seaweed culture that is the least sustainable? Drying, transportation, water consumption?
I would say that probably I would say that drying would have to be, if you're drying it using conventional, but if you're drying it using conventional drying methods, either freeze drying it or doing that consumes a considerable amount of energy. But the way we're looking at it is we've got a circular manufacturing where we're going to be creating soil amendments from the product, and the heat that's produced from producing the soil amendments is going to run our spray dryers. So we're going to fundamentally, our hope, and that's why we're working with the Stanford group, because the only thing left over in terms of energy is the energy that we're using to bubble the tanks. And we're looking to minimize that by about 90% using AI and machine learning, because the only time our seaweed has to bubble is when the sun's out. So theoretically, you could have a farm, so when the clouds go away, it stops bubbling and it comes out, and that kind of thing. So that's where we're at there. But the trade-offs are exceptional in terms of what we can improve versus what they're doing, for example, in the open ocean.
Rebecca asks, are you working with your chef contacts to create recipes that can be shared to get traction for use in industry or at home through application recommendations?
Yes, and we're always looking for additional chefs and people to partner with as well. We have, and again, the famous beginning story of this was we got a small grant to work on this, and with the Food Innovation Center. And for those of you in the audience that don't know the Food Innovation Center, you should, because it's one of the more fabulous things Oregon State and the state of Oregon have done. I'm not a huge government guy, but the idea that for the Food Innovation Center came when Oregon decided, let's put the Oregon Department of Agriculture and the food scientists from Oregon State in the same room. And they did this at the Food Innovation Center, and that created some spectacular results. Now, as we got along with this, we realized that the food, or that the dulse, had a lot of applications. And we were literally in a meeting at the Food Innovation Center, and they said, well, the group said, and a lot of students were involved, they said, we think we should try this as a fresh ingredient. And so I said, well, that's great. I can, who do we know? And they all, Sarah Masoni, who works at the Food Innovation Center, knew Vitaly Paley, who was a James Beard Award-winning chef. And I took a cooler over to him on a Thursday, and I gave him this cooler, and I'll never forget what he looked at me, and he looked at this red leaves, and he says, what do you want me to do with this stuff? And this is back in 2015. And I said, well, you're the fancy chef, that's your job. You figure it out. And I left this with him. And that was a Thursday night. On a Sunday night is when he called me. And he said, Chuck, I got to get more of this stuff because I've put some in the deep fat fryer, and it tastes like bacon, and I'm serving it to all my customers. And I said, you got to be kidding me. And that led to a really funny story, because of course, the next week we were on the Today Show, and we were feeding seaweed to to Al Roker, and he was explaining how great the stuff was and how it tastes like bacon. And we got a call from somebody up in, and it was New Brunswick. It was and Gil Sylvia got the call because he was on the press release, and he had been out of town, and he had 37 messages when he got back. And he called me up, and Gil said, "Chuck, we got a huge problem." And I go, "What?" And he goes, that we just had this huge press release where we have a seaweed that tastes like bacon and it's gone viral, et cetera, et cetera. And he says, "I just got a call from a guy that claims in Nova Scotia that," he says, "we've got dulse up here that tastes like bacon. You guys at OSU are frauds." He said, "We have a restaurant here that has a dulse lettuce and tomato sandwich." And he was really worried about that. Gil was, as the scientist. And I said, as the marketing guy, I looked at that. I said, "No problem, Gil." I said, "Here's the cell phone of the producer for the Today Show." I said, "Give the cell phone number to the guy in Nova Scotia and have him call the Today Show and say he wants 5 minutes on national television because he's got a seaweed that tastes like bacon too." And of course, in marketing terms, the cat is out of the proverbial bag. Oregon State University forever will be known as the birthplace of the seaweed that tastes like bacon.
Thank you. I think we have time for one more question. And for those of you who have posted others that we couldn't get to, my apologies, but we will definitely share those with Chuck and he will happily answer those offline. So thank you for sharing them. Javier asks, what type of cultivation system are you proposing? Is it tanks, bioreactors, raceways, or other?
Javier, I was counting on that question before the end. We have a plan for a 30-acre site that we're going to be announcing probably within 30 days. And this will produce, I don't know the exact number, but it will be a combination of both tanks, raceways, and other features that we've designed into the product. And the purpose of that will be, again, to produce a high quality product to our specifications at the lowest marginal cost so that we can price it any way in the marketplace and still give a significant, and I mean a very significant return to our shareholders, Catapult Ocean being one of the first.
Thank you, Chuck. Any closing comments, Chuck?
Yeah, I just wanted to say I'm really excited that this was a large group of people. It's no secret that seaweed has become vogue in the last thing. I'm a little upset in the sense that you're getting reports that seaweed is curing COVID and it's going to, and that is expected in sort of as this thing expands. But all I can tell you is what our company is focused on. And right now, we're the only ones. There's several others, but we're the only ones doing what we're doing. And we've got the backing of one of the finest investment banks in the world, and we're going to expand really rapidly. And I'm sure that Oregon will benefit. The Oregon coast will benefit. Oregon State University will benefit. And the world will be a better place in 10 years because of what we're doing.
Excellent, thank you. Well, thank you so much for a fascinating presentation, and clearly based on the number and quality of questions, there's a lot of interest in the topic. So I wanted to thank our attendees again today for taking the time to join us and really for your engagement. We appreciate kind of hearing what's on your mind and hope this was interesting and helpful to you.